Hello students, today we are going to start with next chapter, coordination compounds. This chapter is very important both from CBSE point of view or from your JEE as well as NEET. Every year one or two questions have been asked in JEE as well as NEET from this chapter. And in CBSE this chapter is for 3 to 4 marks. Now coordination compounds are the backbone of modern inorganic, bioinorganic and chemical industry, right? And you might have come across, you might have heard in your junior classes you have studied about the process of photosynthesis. So that photosynthesis is a process of manufacturing of food by plants due to presence of a pigment that is chlorophyll. So this chlorophyll is a coordination compound, right? And it contains magnesium. It's a compound of magnesium. In the same manner, hemoglobin, that is red colored pigment in our blood, right, which acts as oxygen carrier, again it's a coordination compound of iron. Vitamin B12, it is a coordination compound of cobalt. So there are so many naturally occurring coordination compounds also, right? These coordination compounds, they find important application in purification of metals. For example, nickel, zirconium, etc. These are purified. We will take up this in another chapter. So in purification of metals also, right? Then these coordination compounds, they are also useful in extraction processes of metals. For example, silver and gold. Again, this we will be taking up later on. Then in +1 you have already studied hardness of water, resins that we have used, right? So these all were complex compounds or coordination compounds. Then they are used as catalyst for many industrial processes. Then they have many applications in electroplating, textile dyeing, and then medicinal chemistry, right? So we can say that this chemistry of coordination compound is an important and challenging area of modern inorganic chemistry. Now first of all, we'll discuss about objectives. What will be the outcome of this chapter? So after completion of this chapter, you will know about the meaning of certain terms such as coordination entity, central atom or ion, ligands, coordination number, coordination sphere, coordination polyhedron, oxidation number, hemoleptic and heteroleptic complexes, right? Each of this one by one we will discuss in detail. Then we will also learn about the rules of nomenclature. How do we give the name IUPAC nomenclature for coordination compounds, right? Their formulas, how to write the formulas and name of mononuclear coordination compounds. Then different types of isomerism. This is again important part. Isomerism in coordination compounds, although it is similar as we have discussed in +1, but the terms will be different, right? Then we will also understand the nature of bonding in coordination compound. Again, this part is important, why they are called coordination compounds in the form of various theories. Werner's coordination theory we will take up, valence bond theory we will take up, and then elementary idea about crystal field theory is given. Then stability of coordination compounds, how stable they are and how when they are formed, right? And then important application of coordination compounds, these coordination compounds in our daily life. So we will discuss or after the completion of chapter, these points will be clear in our mind. Okay. Now we will start up with coordination compounds, right? Now, as we have already studied in previous class about transition metals, and in transition metals a property was there that they form large number of complex compounds, right, in which metal atom are bound to a number of anions or neutral molecules, right? So complex compounds, our main focus will be on complex compounds, right, in this chapter. But before that, we will take up what are types of compounds, various types of compounds. So they can be classified as, first of all, simple compounds. Again, this part is very important. Simple compounds. For example, you know, sodium chloride, potassium chloride, sodium sulfate, in the same manner potassium cyanide, etc. There are so many compounds. These are simple compounds. Why these are called simple compounds? Because, for example, if we take NaCl, so NaCl, when it is dissolved in water, what happens? Once this NaCl get dissolved, it will dissociate into ions, and it will result in the formation of sodium ion in aqueous plus chloride ion in aqueous. Is it clear? Simple compounds means which are formed of simple ions, or which on dissociation gives simple ions. In the same manner, if we talk about sodium sulfate, so this sodium sulfate, when it is dissolved in water, it will result in the formation of 2Na positive plus sulfate ion, SO4 2 negative. Okay. So again, the ions which are formed, they are simple ions. So I think it is clear to you that what are simple compounds. Now the second type of compounds that we will discuss, that is addition compounds. Now these addition compounds, they are further classified into two types. Okay. So addition compounds, for example, when aqueous solution of potassium sulfate K2SO4 and aqueous solution of aluminium sulfate, right? Aqueous solution of potassium sulfate and aqueous solution of aluminium sulfate, their crystallization, they are recrystallized, right? Their crystallization is carried out. You have done this crystallization in practicals. So that crystallization point is attained, and then we get crystals. So crystals of K2SO4 Al2SO4 whole thrice dot 12H2O. This compound is formed, right? So now as you can see that this is formed by combination of two different compounds. So such compounds are called as addition compounds. Now what happens when such compounds are ionized? So on ionization, it will again dissociate into its ions, right? So addition compounds may be formed by more than two simple compounds or ionizable compounds. And finally, what happens on ionization? It will dissociate into simple ions, that is 2 potassium ions, then aluminium ions, and 4 sulfate ions are formed, right? But in this case, you will find that there are 2 different cations and 1 sulfate anion. I hope it is clear. So such compounds come under addition, under the category of addition. And this is called as, I think you know this is called as potash alum. This is potash alum. Okay. Then in the same manner, there is another compound. This is again addition compound. When ferrous sulfate and ammonium sulfate, ferrous sulfate, aqueous solution of ferrous sulfate, and aqueous solution of ammonium sulfate. Their recrystallization is carried out. So we get this compound. This compound is again well-known compound. We call it as, this is called as Mohr's salt, right? Mohr's salt. When it is prepared, when aqueous solution of ferrous sulfate and ammonium sulfate, they are again recrystallized. So this is Mohr's salt, and these compounds, they are called as double salts. Double salts. So this is one category of addition compound, that is double salts. Now how it will ionize? So it will result in the formation of Fe2 positive plus ammonium, NH4 positive ions, and what else? Plus sulfate ions. So again, this compound on ionization have resulted in simple ions. And again, if you see this, so there are two cations, two simple cations, but one anion is there, right? So addition compounds, they can be categorized in one form as double salts. Now we have another compound. This is potassium ferrocyanide, K4FeCN6, and this is formed by combination of again two simple salts, that is potassium cyanide and ferrous cyanide. Potassium cyanide and ferrous cyanide. So this complex is formed, or this compound is formed. Now this species on ionization, when ionization is carried out or by dissolving it in water, what will happen? It was found that there were formation of 4K positive ion plus FeCN6 4 negative. Ferrocyanide ion is formed. Now can you see the difference? That after ionizing this species or after dissolving this species, this compound, it has resulted in a simple potassium ion and a complex anion, ferrocyanide ion, is formed. So I think it is different from the double salts, right? So such ion, this ion is combination of ferrous and cyanide, means in water they doesn't go ionization. So such an ion is called as complex ion, right? Now this is totally different from that of double salts. So the second category, that is, first one was of addition was double salts, and now this second category will be called as complex ions. In the same manner, we can take another example. For example, Cu NH3 4 times and then sulfate. Now this is again example of addition compounds. Now on ionization, when it is dissolved in water, there was formation of Cu NH3 4 times 2 positive, this cation is formed, plus SO4 2 negative anion is formed. Now this is the ionization. Again you can see that this Cu NH3 4 times 2 positive, this is cation. Again this cation is a complex ion, right? This is a complex ion, whereas sulfate, simple sulfate ion is formed. So these are complex compounds. We can call them as complex, not ions, complex compounds. We can call them as. Okay. Now let us take up some examples of complex compounds. So we can classify them. Complex compounds. How they can be classified. So first one is cationic complex. Cationic complex. Right? Cationic complex, as we have discussed, or we can take another example of cationic complex as Ag NH3 twice and then Cl. This is cationic complex. How we can classify it as cationic complex? Just see its ionization. So on ionization, it will dissociate as Ag NH3 twice, right, positive plus Cl negative, right? So there will be a formation of this complex cation and simple chloride ion. This will be called as complex cation. Cation because it carries that positive charge. Okay. So this category will be complex cationic complex compounds, right? In the same manner we have discussed the second one, that is anionic complex compounds. Anionic complex compounds will include potassium ferrocyanide, K4 FeCN6, right? K4 FeCN6. As usual, it will ionize as 4K positive plus ferrocyanide ion, FeCN6 4 negative. Okay. So in this case, the complex ion formed carries negative charge. So this will be called as complex anion, whereas simple potassium ion is formed. Then the third category is there. Third category includes ionic complexes. Ionic complexes means that both species, they will have complex ions. For example, Ni NH3 4 times and then it's PT Cl4. Now this is an ionic complex. How it will ionize? So it will dissociate as Ni NH3 4 times, and it will carry 2 positive charge plus the other one will be PtCl4 2 negative, right? So both the ions which are formed, they both are complex. So such species will be called as ionic complexes, right? I hope you are getting this. Now the fourth category is neutral complex. The example is PtNH3 twice Cl2. Now in this case, when it is ionized, so it will remain unionized in water, means it will remain intact. That is Pt just like same NH3 twice and Cl2. So there is no dissociation into ions, right? So such complexes will be called as neutral complexes, which will not ionize into or on dissolving in water. So these were the types of compounds, right? We have discussed about simple compounds. We have discussed about simple compounds, right? NaCl, etc. Then we discussed about addition compounds, in which double salts, these are of two types, that is double salts, very important. And the next category was complex compounds. So dear students, in this chapter our main focus will be on these complex compounds. Okay, complex compounds. Now how they are related or why we call them as coordination compounds we will take up, and then general terms related to that we will take up in next video. Thank you.